Before we get into the designing the logging solution, let's understand the different types of logs first. Table on the screen covers various aspects that you must know when you work on the centralized logging solution. Security logs and application logs are two types of logs generated by systems, applications, and security tools. Both serve different purposes in monitoring, troubleshooting, and securing IT environments. Security logs are primarily concerned with tracking and monitoring security-related events within a system or network. They are crucial for detecting unauthorized access, identifying security breaches, and ensuring compliance with security policies. Common sources of such logs include firewalls, IDS, IPS, antivirus, anti-malware, access control system, security information and event management system. Key content of such security logs will include successful and failed attempt to access a system, changes to user permissions, role, or access rights, notifications of potential threats or security breaches, logs of changes to critical files or configurations, and installation of new software, changes in system settings, or patch applications. And you make use of the security logs to detect and respond to security incidents by analyzing suspicious events, ensure adherence to regulatory requirements by tracking access and changes to sensitive data, and investigate breaches by reviewing the sequence of events leading to a security incident. Applications logs focus on the operational aspects of software applications. They provide detailed records of application behavior, errors, performance metrics, and other runtime activities, which help developer and administrator monitor and troubleshoot applications. Common sources for such logs include web servers, databases, custom applications, middleware, and operating systems. Key content of such logs will include detailed information about exceptions or errors that occur during application execution, metrics such as response time, resource usage, and throughput, records of user interaction with the application such as clicks, form submission, or API requests, details of operation performed by the application such as database transaction or data processing task, and logs that provide insight into the application internal workings, often used during the development. And you make use of application logs to identify and resolve issues by analyzing error logs and understanding the sequence of events leading to a problem. You also make use of the application log to track application performance and detect bottlenecks or inefficiency. You also make use of application log to keep a record of user actions within the application for accountability and debugging. And you make use of the application log to assist developers in understanding application behavior and identifying bugs during testing. So security logs focus on security related events, while application logs focus on the operational and functional aspects of the application. Security logs capture events related to access control, system changes, and security alerts, whereas application logs capture errors, performance metrics, and user activities within the application. Security logs are used for security monitoring, incident response, and compliance, while application logs are used for troubleshooting, performance monitoring, and development. Both security logs and application logs are essential for maintaining a secure and well-functioning IT environment. While they serve different purposes, they complement each other in providing a comprehensive view of system and application behavior, which help organizations ensure security, compliance, and operational efficiency. The diagram depicts the high-level architecture for centralized logging solution. Azure Monitor is a comprehensive monitoring solution for collecting, analyzing, and responding to telemetry from cloud and on-premises environments. By using Azure Monitor, you can build a unified platform for collecting, storing, and analyzing log data from various sources, which will enable comprehensive monitoring, troubleshooting, and security management. The high-level architecture includes log data sources, data platform, and how collected logs can be consumed using various components of the Azure Monitor. Data sources can include application logs, infrastructure logs, Azure platform logs, and custom sources. Application logs are logs generated by applications running in Azure, such as web apps, APIs, and services. These logs can include custom logs, error logs, and performance metrics. Infrastructure logs are logs from virtual machines, networks, storage, and other infrastructure components. These logs provide insight into the operational health and performance of the underlying infrastructure. Platform logs are logs generated by Azure services, including Entra ID, Azure Resource Manager logs, and diagnostic logs from services like Azure SQL databases, Azure Functions, and many more. Custom logs are logs from on-premises system, third-party applications, or custom solutions that are integrated with Azure through various means, such as agents or custom APIs. Data collection and routing are critical processes that ensure log data is appropriately gathered and directed to the right storage locations. These include direct data routing, diagnostic settings, data collection rules, application SDK, Azure Monitor REST API, Azure Monitor agents, and Azure Monitor Managed Service for Prometheus. Direct data routing means platform metrics are sent automatically to Azure Monitor metrics by default and without configuration. Diagnostic settings are configurations that determine what data is collected from Azure services and how it is routed to various destinations such as Log Analytic Workspace, Azure Storage Accounts, or Event Hubs. Data collection rules are used to specify what data should be collected, how to transform that data, and where to send that data. Application SDKs are added to application code to receive, store, and explore your monitoring data. The SDK pre-processes telemetry and metrics before sending the data to Azure, where it's ingested and processed further before being stored in Azure Monitor logs. The Logs Ingestion API in Azure Monitor lets you send data to a Log Analytic Workspace from REST API client. Azure Monitor agent collects monitoring data from the guest operating system of Azure and hybrid virtual machines and delivers it to the Azure Monitor for use by features, insights, and other services such as Microsoft Sentinel and Microsoft Defender for cloud. Azure Monitor Managed Service for Prometheus lets you collect and analyze metrics at scale using a Prometheus compatible monitoring solution based on the Prometheus project from the Cloud Native Compute Foundation. The data platform is where the collected log data is stored, processed, and made available for analysis. Metric stores performance metrics such as CPU usage, memory utilization, and other key performance indicators. Metrics are typically time series data and are used to monitor the health and performance of resources. Log stores log data such as error logs, audit logs, access log, and many more. This data is used for in-depth analysis, troubleshooting, and security monitoring. Traces stores trace data, which include detailed information about the flow of execution within application, such as distributed tracing data that tracks the flow of requests across microservices. Change stores information about configuration changes, deployments, and other alteration in the environment. This data is crucial for understanding the impact of changes on system behavior and performance. The stored log data can be consumed in various ways to generate insights, visual trends, analyze issues, and respond to incidents. Azure Monitor provides built-in insights for various services such as Azure VM Insights, Azure Application Insights, and Azure SQL Insights. This tool provides pre-configured dashboard and alert for monitoring specific resources. Data visualization tools like Azure Dashboard, Power BI, and Grafana are used to create custom dashboards that visualize metrics, logs, and traces, which enable stakeholders to monitor system health and performance at a glance. Log Analytics provides powerful querying capability using Custo query language called KQL to search, filter, and analyze log data. This analysis helps in identifying trends, root cause of issues, and potential security threats. Automated responses can be configured using Azure Automation, Logic Apps, or Azure Function. These tools can trigger actions based on specific log events such as automatically scaling resources, sending alerts, or remediating security threats. Integrating Azure's logging solution with external SIEM system enhances security monitoring and compliance capability. Azure Event Hub can stream log data in real time to external SIEM solutions. This integration allows organizations to centralize their security operations by feeding Azure logs into their existing SIEM infrastructure. Azure provides APIs that allow external systems to import and export log data from Azure. This enables seamless data exchange between Azure and third-party SIEM solutions, which ensure that security events and logs are consistently monitored and analyzed. In summary, the centralized logging solution in Azure is designed to provide a comprehensive and scalable platform for collecting, storing, and analyzing log data from various sources. By utilizing Azure's data collection and routing capabilities, organizations can ensure that log data is efficiently managed and stored in appropriate locations. The integration with external SIEM solutions via event hubs and APIs allows organizations to leverage their existing security infrastructure while benefiting from Azure's powerful logging and monitoring capabilities.